All right, good morning again, everybody, and welcome to week number 3 of Math 151, Ordinary Differential Equations. So, tingnan muna natin kung ano yung mga ginawa natin last time. So, basically, we spent last week familiarizing ourselves with ordinary differential equations, and we said that, we said we can classify ordinary differential equations according to how the actual equations look like, or what are the types of expressions are involved in the ODE. So meron tayong mga tinatawag na homogeneous differential equations. We learned what the order of an ODE is, what is the or whether a certain ODE is linear or not, right? Ano pa ba? And then we also said that we can summarize the goals for this class into 4 things, right? We want to know when will there be a solution to a given ODE, how many solutions are there in an ODE, tapos titingnan natin what those solutions are like. So just a qualitative description of those solutions, and last, what are the representations for that solutions. And the fourth bullet actually would be the focus of the course. Basically, we will be developing ways on how to get a solution, or how to get our hands on the solutions to these ordinary differential equations, or at least yung mga simpleng klase nila, kasi meron din mga ODEs na ang hirap isolve, or they are actually nearly impossible or even impossible to solve by hand. Kaya siguro from time to time, we will look at numerical methods on how to solve ordinary differential equations, and hopefully we can use these tools, yung computational tools, yung numerical tools, as well as the qualitative tools para makapaggawa ng isang project at the end of the semester. All right? So last time, tiningnan muna natin paano magkaroon ng qualitative analysis on doing ODEs, and we said one way to do this is via the use of direction fields. And I think this is where we left off last time. Just a quick review. Gumagawa tayo ng direction fields para makita ano yung behavior ng mga solutions. Even if we are not calculating the solutions themselves, we'll get an idea of how those solutions look like. Ito yung third bullet, yung sa isang picture na pinakita ko sa inyo in one of the slides, right? So one way to do this is doing it by hand, right? And medyo matrabaho nga lang to kasi kailangan nating mag-identify ng different curves, and then we will plot slopes on these curves, and then we should do this as so long as or hanggang makakita tayo ng isang pattern on how we can describe the solution. So if you're given an ODE, say this one, y prime equals negative x over y, all right? So papalitan lang natin si y prime ng isang constant. Right? So for specific values of the constant c that we will assign to y prime. So but first, before that, gusto pala muna nating isulat yung ating solution in terms of yung ating equation in terms of an explicit representation. So gusto ko naka-explicit form muna yung ating ODE. So dapat siya ay itsurang y prime equals an operator x comma y. All right? And this analysis only works for first-order differential equations. So if you have a first-order differential equation, you need to write it first in explicit form. Naka-isolate si y prime dun sa isang side. And then after you do this, you give specific values or specific constant values for y prime. So for instance, si y prime, papalitan ko ng isang constant c, or actually some constant c, say 4 constants or 5 constants. See if those are enough to get a meaningful pattern out of the graph that you'll get, right? So the curves f of xy equals c. So the curve that you will get after you replace y prime by a constant is called an isocline, right? So ang gagawin natin ngayon, iplot natin yung mga isoclines on our two-dimensional plane, all right? So halimbawa, magbigay ako ng c equals 1. So ito yung aking equation. So si y prime, papalitan ko lang ng 1. Makukuha ko tong isocline na ito. All right? After simplification, this is just y equals negative x. So what I'll do is I'll plot this isocline. So yan yung graph ni y equals negative x. And along this graph, I will draw small line elements or small line segments whose slope are equal to 1. Dapat ang slope ng mga ipa-plot natin ng mga line segments ay equal kay 1. Remember, kapag ka meron kang slope na 1, ito ay parang pataas, right? So it should be going up. So tingnan nyo dito sa red curve na to or sa red dotted curve na to or line, magpa-plot ako ng mga line segments na roughly ang slope ay equal kay 1. Okay? And then I'll do this for some other values of C. For instance, I'll get C equals -1. I'll get the isocline Y equals X. Ipa-plot ko uli ngayon si isocline, yan yung Y equals X, and then along this line, I will draw line elements whose slope is equal to -1. Yung value ng C na ginamit ko. Right? So siya naman ay downward the line segment. So that would be my portion of the direction field. Ano? And then do this for some more values, right? As until you get a nice pattern. Okay. So this would be sort of our direction field. And you will see na parang ang pattern dito ay siya ay circular. Circular yung mga solutions dito sa ating ordinary differential equation na y prime equals -x/y. Okay. And then I think we also started doing it the computer way, the mas madali with the program that I shared with you. So tingnan natin. Let's play with the code a little bit more para maging familiar kayo. Kasi pag nag-qualitative analysis tayo, babalikan natin yung paggawa ng direction field. And again, direction fields are easier to be implemented via computer, especially if your function f is complicated. Okay? Lalo na kapag napakahabang conic section o napakahabang relation yung makukuha nyo mula dun sa isocline. Right? So let's look at particular example. Okay. Have we guys tried this one last time? Napakita ko na ba itong example na to? Or hindi nyo na rin tanda? I forgot to check the recording from last time. Nagawa ba natin? Or am I still live? Oh, hindi pa. Okay, so let's try this one. So y prime equals x squared minus y. Let's do this by hand first. Or gagawin natin paano siya, tingnan natin yung steps na gagawin siya by hand. And then let's take a look at how we can implement this in MATLAB, right? So first, x squared, y prime equals x squared minus 9. Make sure you have an order 1 ODE. That's fine because the highest order derivative here is 1. Oops, sorry. Spoiler. Yeah, 1 yung highest order na nandito. That's fine. Is it in explicit form? Yes, because y prime, the highest order derivative, is isolated on the left-hand side. So all the building blocks are all the necessary requirements para magawa yung isocline were already satisfied. Okay. Now what we'll do, replace y prime by a constant c. So we'll have x squared minus y equals c. And then we'll give specific values for c. Sila yung mga isoclines na gagamitin natin para magawa yung direction field. Excuse me, guys. Okay. So now let's see. Let's give no, hindi niya na inisa-isa. Pero for instance, if you give c equals 1, okay, let's give this value c equals 1. So dito, si c papalitan natin ng 1, we'll get y squared equals x squared minus 1. All right? So that would be, ipa-plot ko ngayon, yung unang isocline na yon, and that will be this curve, right? Ito yon. X squared minus 1. So that's this guy, right? Ipa-plot ko yung parabola. Maybe I can plot the parabola this way. Sorry, di pala. Mali yung tinrace ko. Sorry about that. So ito siya. Tapos along this parabola, mag-drawing lang ako ng mga line segments na ang slope nila ay equal kay 1. And then you do this also for a second isocline, y equals x squared minus 2 obtained by replacing c by 2. So maging x squared minus y equals 2. then it will be y equals x squared minus 2. So it's a parabola whose vertex is at 0, negative, 0, negative 2. So that is the parabola passing through this vertex. So ito yan. Tapos makikita nyo along that parabola, I drew line segments na ang slope ay positive 2. So mas steep yung line segments na dinrawing ko dito kasi ang slope nila ay 2 compare the previous line segments that we have drawn. And then you need to do this for much more values of C para makita natin yung pattern. Right? And what you get here, yung collection ng mga line segments, yun yung tinatawag natin na direction field. Right? Isoclines, sila yung mga curves, yung mga dotted curves. Tapos yung line segments, yung collection ng mga line segments, sila yung tinatawag na direction fields. Okay? Now, as I've mentioned, it's nicer probably to do it using a computer kasi nga kailangan pa nating i-review paano mag-graph ng parabola, ng mga conic sections. Although in this particular case, the isoclines are very simple. They are just simple parabolas centered at x equals 0, translated C units up or down the y-axis. So that's fine. Pero pag komplikado na si C, medyo mahirap na yon. So let me go back to the MATLAB code I provided to you last time para makita natin yung paano siya ini-implement. Do I have it here? Open ko lang siya. Okay, there you go. Then I need to go to the folder where I saved it. Okay, there you go. Okay, remember, yung line number 3 at saka 5 lang yung kailangan yung baguhin dun sa code, right? So yung line number 3, babaguhin nyo etong inputs na to kung gusto nyo baguhin yung window. Kung meron kang ibang x interval na gustong i-consider at saka y interval na gustong i-consider. Now, the highlighted portion of the code tells us that what we will be plotting would be the direction fields over the x interval negative 2 to 2 and the y interval negative 2 to 2, and the spacing between the values of x and y are both 0.2. Kung gusto nyong mas dense yung pagkaka-drawing ng direction fields, pwede nyong paliitin etong increment na to. Right? So yung middle number in this sequence na separated by colons, sila yung nagsasabi kung gaano kalaki yung jump from one x value to another. So this highlighted part of the code tells me that I will create a mesh of points or a collection of points on the x-axis starting from negative 2 of increment 0.2 hanggang makarating ako kay 2. So nababasa ni MATLAB from that vector ay negative 2, negative 1.8, negative 1.6, negative 1.4, all the way hanggang makarating siya kay 2. And ganun din yung sa y value. So you can make it say 0.1 para 0.1 lang yung increment. So mas dense yung, or mas marami tayong points na kung consider, mas marami tayong line elements na makikita. So sorry guys, I need to excuse myself from time to time. Umaatake yung runny nose ko. Kaninang 174 wala pa to eh. So sorry about this. Lagi yung sumasabay, yung runny nose ko na yun. Tuwing may klase, lagi siyang active. Pero pag wala namang klase, wala siyang pakialam. So yeah. Okay, let me just clear my command window here. Okay, there you go. And then, so, kung settled na kayo dun sa mesh grid na gusto nyong gamitin, so, keep it that way. And then, sa line number 5, dun nyo i-input kung ano yung ODE. Ano yung right-hand side ng ODE, right? Remember, our function f is the right-hand side in our explicit ODE. So, dun sa ating problem, ang y prime natin ay equal kay x squared minus y. So, that means our f is x squared minus y. Kaya lang medyo kailangan sundin natin yung convention ni MATLAB kasi si MATLAB specific yung syntax niya. So para ma-input yung x squared, what I'll do is write the variable x. Ibig sabihin kukunin niya yung vector ng mga x values na nanggaling sa line 3. Pero pag mag-square kayo ng vector kay MATLAB, gusto nyo ay component-wise yung ini-square. Meaning yung mga laman ni vector x, yung i-square nyo isa-isa. Ang syntax na gagamitin natin ay dot, caret, ito yung x squared. So, kailangan yung mag-insert ng dot bago yung raised to the second power. Alright? Minus the vector y. Capital yung ginagamit ko kasi capital X and Y yung pinangalan natin dun sa mesh grid. Okay? Now, after I have edited the lines 3 and 5 according to the problem, I can now press the run button here at the top tab, or you can press F5 on your keyboards. If you press run, I'll get this direction field. Okay. So that means this is how the solution behaves over the interval -2 to 2. Right? And this is similar dun sa nakuha natin doon sa tama ba? Similar to dapat dun sa nakuha natin sa slides. Let me shift to the slides a little bit. Okay. Okay. Medyo limited yung nasa slides kasi x squared minus y. Ang kinonsider niya lang ay isang portion ng ating direction field. But bakit magkaiba sila? Hold on. X squared minus y. Tama ba? X squared minus y. X squared minus y. Okay. Let me see. Okay. So parehas lang pala. Ito yung mas malaking view. And I think that is what we got here. Okay. And the thing about this is that if you know if you have a direction field, you can get a specific solution na magpa-pass through to a certain point. So yun yung sinasabi na pagkuha ng isang integral curve given the direction fields. Kasi yung direction field siya yung nagsasabi ano yung slope ng tangent line doon sa particular point in the solution curve. Or basically, yung mga line segments o mga line elements na nakikita natin dun sa direction field, yun yung tangent lines or portions of the tangent line passing through individual points. So for instance here, let me turn on my annotation here. Okay. Maglo-load siya. Pero halimbawa, gusto ko ng isang specific solution. Because if you trace any of this direction fields, kaya mas maganda sa direction fields yung merong arrow, kaya mas gusto ko siyang ginagawa kay MATLAB. Pag tinrace mo yung behavior doon sa direction field, sinundan mo sila, nag-drawing ka ng isang solution curve using this direction fields or this line elements as your slopes as your tangent lines, makakuha ka ng isang solution. For instance, I want to get the solution passing through 0, 0. So hanapin mo lang yung point 0, 0. X is 0, Y is 0. So I'll get, say, parang itong point na to. Okay? Tapos, sundin mo lang yung direction field na gagamitin mo na tangent line doon sa particular points yung mga nakadrawing na line elements. So, rito, ito yung arrow. So, ito yung susunod na slope. Ito yung susunod na tangent line, susunod na tangent line, susunod na tangent line, and then it will be going up, up, up. Napasobra ako ng up doon. And then it will be going up, going up, going up. So that means, and then dito siya nagmumula. So you can say that a solution passing through 0, 0 will be this curve. Ito yung isa sa mga solution, okay, doon sa ating differential equation. So we get a solution to the differential equation even though we haven't solved the ODE yet. At yung sinasabi natin, ano yung itsura ng mga ODE, ano mga solutions ng ODEs, how they behave. And you see, this is much more of a qualitative assessment or a qualitative description of the solution. Kasi hindi pa natin binibigay kung ano yung itsura talaga ng solution. Pinakita natin yung isang rough sketch kung paano magbe-behave yung solution. Right? So you can find other solutions by riding the solution curves a little bit. So you get something like that. Or kapag ka nandito ka, medyo mas steep yung mga solution. All right? And so on. So just play around it. Siguro i-print nyo as a PDF yung figure na makukuha nyo kay MATLAB. And then you can do the careful plotting of the points. Yun nga lang, pag may direction field ka, tandaan, kapag ka gusto mo makakuha ng isang specific solution to the ODE, you need to find what's the condition, ano yung initial condition dun sa ODE, hanapin yung corresponding point na yon doon sa direction field, and then follow the arrows. Okay? Does that make sense, guys? Any questions? Tanong? Wala pa naman masyadong tanong? Pwede ba ako magpa-homework 3 na direction field yung gagawin? Okay lang ba? Yeah, I think that's what I'll do. I'll ask you to do a direction field as a homework for this week. Okay. But let's do that later. Paano ko nga to off? Okay, there we go. Okay. So let's see another example. Let me go back to the PowerPoint. Okay. Right, more examples na. Pero parang delayed yung slides ko. Okay, there you go. Another example. So let's have y prime. Let me just copy it on my notes. Y prime equals 1 plus x minus y. Again, this guy, kailangan muna natin i-check if this is already in the desired form. First, it is of order 1. The highest derivative is of order 1. And it is in explicit form because y prime is isolated on one side. Okay, so that means our function f here, our f of xy will be 1 plus x minus y. Oops. Minus y. Ngayon, gagawa ko ng mga isoclines. Diniretso niya na pala. So, kung by hand, so gagawa ka ng isoclines, bigay ka ng specific values for y prime. So say if c is equal to 1, so I'll have 1 equals 1 plus x minus y. The y's will cancel each other out, so we'll have y equals x. That's our first isocline. First y equals x, that is this line over here. Ito siya. Lagyan ko ng arrow si y equals 1. Okay, how do I do? Oops. Anyway, so ito yung y equals 1. Tapos kay y equals 1, segments ng, sorry, ng slope ay 1. Mga line elements ng slope ay 1. So that's how you got this part of the direction field. Okay. And then you give other specific values for C until you generate this graph. Okay. Madali lang siya kasi napaka-simple nung ating f of x, right? Or f of x comma y. And then in general, this would be your isocline. Okay. There would be no problem in doing it in math lab kasi ngayon, balik natin dito. Oops. Delete ko na yung figure kanina. So kailangan ko lang baguhin si line number 5 again. I'll just have to write it as 1. Okay, sorry about that. I think I got cut off. The direction field that you'll get. Okay. Then again, if you want to see a particular solution, sipin mo lang, saang particular solution yung gusto kong ma-obtain. So, halimbawa, sabi sa problem, you want to get a specific solution at x equals 1 and y equals 1. So, hanapin mo lang, nasan yung 0.11 dito sa ating direction field. So 1 is here, x equals 1, y equals 1 is over here. So yung point corresponding to 1, 1, maybe somewhere here or somewhere here. Yun yung direction field. So yun yung slope ng tangent line. So yung mga line elements, sila yung representation ng tangent lines to those points. Tapos just connect them, follow the arrows. You'll get the specific solution. It seems that at this particular point at saka dun sa mga katabing point ni 1, 1, parang straight line lamang yung solution. Kasi ganun yun yung pinopoint ng ating direction lines, right? Pero kapag halimbawa nandito ako sa portion na to, okay? Parang medyo mas curvy yung solution na makukuha ko kasi pag tinrace ko yung solution curves, ganun yung magiging itsura nila. Pag nasa baba naman ako nung line passing through 1, 1, parang yung solution curve, mga ganito yung itsura. Right? Mas steep sila na mga curves. So again, here, we are having a more qualitative description about the solution. Actually, not just a single solution, but all of the solutions or a family of them and how they behave for different initial conditions. Okay? tingnan ko kung meron siya sa slide. Let me just clear this up and annotations. I'll go back here. Okay. So, and then that's the same behavior that you see from the picture on the slides, right? So makita nyo, nag-iiba talaga yung behavior ng mga solutions when you start at a different initial condition. Pag yung initial condition mo ay nandito, talagang napaka-steep ng mga curve. Dito, medyo mayroon pa siyang pa-kurbada dun sa baba. Umiikot pa siyang pa ganun. Pero kapag ka nandito ka sa y equals 1, almost straight lagi yung mga solutions. Okay? Kaya to more of qualitative. Ano yung itsura ng mga solutions, even though we don't know the solutions yet. Okay? So I hope it is clear to you by now ano yung difference ng isocline, ano yung versus direction fields, at ano yung implications ng pagkakaroon ng direction field. Okay? Now, all right. Now, so meron na tayong idea of how we are doing the third question, how we are answering the third question. Dun sa 4 questions na sinabi ko sa inyo last time that will describe our Math 151 journey. Now, let's try to see paano naman natin i-address yung question about the existence of a solution and actually for that, there are lots of results, pero ang pinakamadali, at least for a first order ODE, first order ODE, ay yung theorem ni Picard. So what you have on the slide right here is what we call Picard's theorem. It's also known as the Picard-Lindelov theorem or the Cauchy-Lipschitz theorem. Okay? Anong sinasabi niya? Well, this theorem, in summary, gives us a sufficient condition when can we conclude that a given first order ordinary differential equation has a unique solution. Okay? So let's see what the theorem says. So sabi niya, pag meron ka raw IVP na ganito yung itsura, when we say IVP, it's an initial value problem. So you have your ODE with you. Dapat naka-explicit form siya. So bago i-apply si theorem, make sure meron kang first order ODE at saka dapat naka-explicit form siya. Pag nasulat mo siya sa explicit form na y prime equals f of xy, and then you're given the initial condition, x0, y0, dalawang bagay lamang pala ang kailangan mo i-check. Kailangan mong i-check kung si f ay continuous sa isang rectangular region at saka kung yung partial derivative ni f with respect to y ay continuous then in the same rectangular region. If you can find a rectangular region that includes the initial point x0, y sub 0, kung saan continuous parehas si f at saka yung partial ni f with respect to y, then your initial value problem has a unique solution. Ibig sabihin, you can only find one and only one integral curve of the solution of equation 1 that passes through the point x0, y sub 0. So this is partly, or this will give us an idea how to answer yung first 2 questions. Kasi sabi ni Picard, madali lang yan. Para masabi na may nag-exist na solution at unique yung solution na yon, here's the sufficient criterion. I-check mo kung yung f at saka yung partial ni f with respect to y ay continuous sa isang rectangular region na nagko-contain nung iyong initial value. Okay? So that's the theory. Let's see this in action. Paano siya na-apply? So let's start with this one. So y prime equals y minus 1 all over x. Question, is it in explicit form? Yes, because, hindi pala muna explicit. Is it a first order ODE? Yes, because the highest derivative that we see here is of first order. Okay. Second, is it in explicit form? The highest order derivative is isolated on the left. So this is indeed in explicit form. It's an first order explicit ODE. So we're good. We can apply Picard's theorem. Sabi ni Picard, i-identify mo sino si F, sino yung operator F that describes your ODE. Well, what's happening? Sorry. Okay. My slides were messed up. So, let me see. Hold on, guys. Okay. Dapat i-check natin kung paano magpakita na may nag-exist na unique solution using Picard's theorem. Pero I guess something happened to my slides. Let me double check. Okay. While I'm looking for the right slides, do you guys have any questions? I hope everything is clear so far. Oh, by the way, I forgot to comment on the first homework. Tama ba? Homework number 1 pa lang natin yon, no? Or homework 2 na ba? On the last homework, by the way, for those who joined us a little late, na-gradean ko na yung homework. Yeah, thank you, Kiefer. Homework number 1. So you should be able to see your graded work in Canvas. Most of you got perfect scores. Yung iba, medyo nasobrahan na pag-differentiate. So remember, you can only differentiate or you can differentiate n times, provided that there are n parameters. So you can differentiate as many times as you would like, as long as that number is less than or equal to the number of parameters present in your ODE. So kung meron ka lang isang parameter sa ODE, isang beses ka lang pwedeng mag-differentiate. Otherwise, ano ba yung epekto ng pagkakaroon ng maraming pagdi-differentiate ng sobrang dami? Well, yung ODE na makukuha mo ay solution lamang, ay hindi lamang solution para dun sa family na binigay dun sa question, pero meron pa siyang ibang mga functions na solutions din niya. Right? So for instance, I asked you to get a family of, to get an ODE that will whose solution, sorry, if I ask you to find an ODE for a specific family of curves na meron tatlong parameters. So that means to make sure that only the members of those family will fall as or will be a solution to the ODE that you'll get, kailangan hanggang tatlong beses ka lang magdi-differentiate. Pag nag-differentiate ka pa ng 4 na beses o mas mataas pa, ibig sabihin yung ODE na makukuha mo, ang solutions ng ODE na yon ay hindi lamang yung family na binigay ko sa'yo consisting of 3 parameters, but it can admit some other families as a solution. Kaya constrained kayo na mag-differentiate lamang kung ilan yung parameters. Kung 3 parameters yung family, 3 beses ka lang mag-differentiate and you need to work with whatever you get. Kung isa lamang yung parameter, isang beses ka lang pwede mag-differentiate. Kapag ka 5 yung parameters, lucky you can differentiate 5 times. Okay? Pero wag ka na magdi-differentiate ng 6 na beses kasi yung solutions nung 6th order ODE na makukuha mo ay hindi lamang yung family na binigay ko sa'yo. Meron pang ibang mga makakasama doon sa solutions. So para magkakaroon ka ng extra solutions, all right? So you are not getting an ODE for the specified family, pero you are getting much more, all right? You are getting an ODE that has a larger solution set than the family that you were given, all right? So yun yung explanation kung bakit hanggang n times ka lang pwede mag-differentiate kapag ka ang family mo ay what do you call this? Ay n parameter. Okay? So, I guess okay. Ako na lang meron ako. All right. So, y prime equals y minus 1 over x. It is a first order ODE, right? And it is an explicit form. So we can check the existence or the uniqueness and existence of the solution using Picard's theorem. So in this particular example, our f of x is equal to, oops, why is it doing that? Y minus 1 all over x. Okay? Siya si f natin. Tapos what can you notice about f? Saan continuous si f? Anyone? Remember, ang usapan lamang natin, ang sabi ni Picard, i-check mo lang saan continuous si f at saka si partial ni f with respect to y. then kapag ka alam mo na kung nasan yon, alam mo na kung saan siya continuous, malalaman mo na kung saan initial conditions magkakaroon ng unique solutions. Okay. Answers are coming in. Thank you, Reynold, Drensis, Victor, Kiefer, Zai, Justin, and Jim Brethren. Yeah. This function f is continuous whenever x is not equal to 0. Okay. So ito ay continuous. Ito yung notation natin sa continuous. Continuous siya sa lahat ng real numbers or actually mahirap pala siyang isulat symbolically. Let me just erase this. I'll just mention it verbally. Kapag ka sa solution nyo, kailangan yung isulat that f being equal to y minus 1 over x is continuous for all x's not equal to 0. Right? And then kunin mo yung partial ni f with respect to x. So, with respect to y, ang sabi ni Picard's theorem. Pag kinuha natin yung partial ni f with respect to y, so that means all variables except y will be treated as a constant. So x is treated as a constant, so magiging multiplier lang siya, 1 over x. Then partial ni y minus 1 with respect to y will just be 1. Right? Partial ni y with respect to y equal kay 1. So this is the partial of f with respect to y. Saan continuous yung partial derivative nito? So this partial derivative is still continuous for all x's except when x equals 0 pa rin. So ibig sabihin, as long as our rectangle doesn't contain the points where x is equal to 0, then there will be a unique solution. Yun yung part, right? So let me just go back to Picard's theorem. If you can find a rectangular region around the initial condition x0 comma y sub 0, where f and the partial of f with respect to y are continuous, then the IVP will have a unique solution. Now, in our analysis here, we have found that since f and the partial of f with respect to y look like these two guys, then basta yung initial condition natin ay hindi nagsisimula or hindi yung initial condition ay hindi x equals 0, then we're good. We can find a unique solution. And the converse of Picard's theorem tells us kapag ka discontinuous, sige, analyze natin yung Picard. So, karamihan sa inyo, mga naging estudyante ko ng 101, no? So, pag meron kang P, si P ay f and the partial of f with respect to y are continuous, then there exists a unique solution. Unique solution. Pag hindi unique yung solution, ibig sabihin si f at saka yung partial ni f with respect to y ay hindi continuous. So hindi ko pala magagamit. Ang statement ni Picard's theorem dito ay one direction lang. So the only thing we can say is that when f and the partial of f with respect to y are both continuous on a rectangle that contains the initial x value, then there will exist a unique solution. Otherwise, no conclusions can be set, right? So if you look at the direction curve, let me just clear this up. Okay. Tingnan natin kung totoo nga ba yung Picard's theorem, ano? So let's see. Tingnan ko yung mga isoclines. Pagka si Ci equal kay 0, we'll get y equals 1. Ito yun. Tapos, drawing ko yung mga solution curve. And when C equals 1, we'll get this. Yan yung direction, yan yung line elements, and so on. Right? So if we'll be looking at, say, the initial condition, say 1, 1, okay? So 1, 1, ilan yung mga solution curves na daraan when x is equal to 1? Actually, the initial condition there is 1, ay dalawa, actually infinitely many pala, pero magbigay ka ng isang specific initial point. The initial point, say, is 1, 1. And since if we go back to how f and the partial of f with respect to y looks like, we can always find a rectangle containing the point 1, 1 kung saan continuous yung f at saka yung f with respect to y, right? Kasi liitan mo lang yung rectangle, basta hindi niya kasama si x equals 0, then okay ka. Continuous lagi si f at saka si partial of f with respect to y sa rectangle centered at 1, 1 as long as it doesn't contain 0, 0. So ibig sabihin, sabi ni Picard's theorem, there exists a solution. Actually, not just that. There exists a unique solution passing through 1, 1. Kasi nga, merong rectangle that contains 1, 1 kung saan continuous parehas si f at saka si partial ni f with respect to y. And that unique solution would be this guy. Itong straight line lang din na yan. Okay? Now, halimbawa, sa negative 2, negative 1. So where's the point negative 2, negative 1? Ito yan. Tapos, i-trace mo lang yung direction fields. Ito yung makukuha natin. Oh, meron akong nakuhang isang solution. Siya lang ba yung nag-iisang solution na pwede kong makuha? I'm sure yes. Siya lang yung unique solution kasi sabi ni Picard, dahil si f at saka si partial ni f with respect to y ay continuous sa isang rectangle na nagko-contain kay negative 2, negative 1. Sure ako kasi ang points of discontinuity lang naman ni f at saka ni partial ni f with respect to y ay nagaganap kapag si x ay equal kay 0, then I'm good. F and the partial of f would be continuous at over this rectangle. So eksaktong isa lang yung solution kung mahanap. However, at points when x is equal to 0, say at 0, 1, imposible tayong makahanap ng rectangle na nagko-contain ng point na 0, 1 kung saan continuous si f at saka yung partial ni f with respect to y. Kasi alam na natin na parehas si f at saka si partial of f with respect to y ay discontinuous kapag si x ay equal kay 0. So kapag ang initial condition mo ang itsura ay 0, y, either there will be no solution or there will be infinitely many solutions or more than one solution at least. And that's what we see here. Tingnan niyo yung 0, 0. Ilan yung posibleng solutions na makuha natin na magpa-pass through sa 0, 0? Sabi natin, para makakuha ng integral curve, o makakuha ng graph ng isang solution, sundan lamang natin yung mga direction, yung mga line elements, yung direction field passing through 0, negative 1. One of them is this guy, right? Nag-pass siya ng 0, 1, isa siyang direction field. So this is one solution. Let's call it y1. However, if I trace this direction, this line elements over here, I get another solution. Call it y2, and so on. Hindi unique yung solution sa 0, 1. All right? And the other characteristics of solutions passing through the line x equals 0 is a question mark, right? Yung mga solutions na daraan dyan kapag si x ay equal kay 0, sure tayo na hindi unique yung solution. Okay? Actually, sure tayo na hindi unique yung solution. So, ibig sabihin, meron kang maraming solution o wala kang solution at all. Pero outside of those points, we are sure that lagi magiging unique yung solution. Okay? So we will revisit the application of Picard's theorem later when we do some more qualitative analysis. Pero do you guys have any questions about the introduction to Picard's theorem? Madali lang naman siyang i-apply, ano? Hanapin niyo yung si f, tapos yung partial ni f with respect to y, tingnan kung kailan siya continuous. Alright? So I guess that ends chapter 1 ng course. So probably okay, siguro pili kayo, ito na yung homework number 3 natin, homework number 2, sorry. Dito na ba tayo pumili? Okay, so let's do this. Choose one among these 5 problems. Tapos, instruction lang naman, create a direction field. And then, sketch for me one integral curve. So, i-send ko naman mamaya sa Canvas ulit yung detailed instructions. Pero basically, what I want to do, I want you to do is to choose exactly one among these 5. Pili lang kayo ng isa. Tapos, i-drawing nyo yung direction field. Pili kayo ng direction field. Tapos, pag nag-graph nyo na yung direction field, either by hand, you can do the isoclines thing. So, mano-mano nyo siyang gawin. Or you can use the MATLAB thing, right? I-run nyo lang siya sa MATLAB. Tapos, after you have the direction field, mag-trace kayo ng isang integral curve. Plus, get one integral curve. Bahala na kayong kung saan dadaan na point. Alright? Is that okay? Kailan nyo gustong i-deadline to? Kailan nyo gustong i-deadline? Any suggestions? Oh, if you're thinking of doing letter C in MATLAB, ang gawin nyo lang ay F equals cosine cos ng Y. Yun lang yung syntax para sa cosine. Okay? Or maybe I can also show you how the other one is done. Habang nag-iisip kayo kung kailan natin i-deadline. Pero i-drawing natin kay MATLAB yung direction field ng Y prime equals Y minus 1 over X. So let me go to MATLAB. Okay, there we go. Okay. So papalitan ko lang naman itong F, right? Paunting ko lang yung line elements. So gawin ko lang itong 0.2 to 0.2 para mas makita natin yung behavior. Para ko konti lang yung plot. Konti lang yung line elements. Tapos, kailangan kong i-type ay Y minus 1 over X. So una, i-parenthesis ko muna yung Y minus 1. Ang gagawin ng Y minus 1, kukunin niya yung vector ng mga Y values, pero maminusan niya bawat isa by 1. So yun yung gagawin ng Y minus 1. So it's okay. Lahat ng elements ni Y, maminusan niya ng Y. Pero kailangan, sabi nung Y prime natin, it's Y minus 1 over X. So bawat isang laman nung vector na to dapat ma-divide by X. So to ask MATLAB to do that, ang gagawin natin ay Y minus 1 dot divide X. Kasi nga gusto ko yung corresponding entry on the vector Y ay i-divide by its partner na naka X. Kaya meron tayong dot divide. Kasi kung hindi nyo yan i-dot divide, ang gagawin ni MATLAB, gagawin niya, imumultiply niya ng X inverse. Medyo may linear algebra na doon. Hindi siya mag-work lagi. And actually, hindi yun yung gusto ko. Kasi ang gusto natin gawin, yung magkaka-partner na elements, sila yung pag-divide natin. So this is how you do term-by-term division in MATLAB. And then let's press run. Tapos ito yung direction field. Tapos makikita nyo, kahit si 0, 0, ay kasama dapat doon sa ating gagawa ng direction field. Hindi nagawa si MATLAB ng direction field dito. Kasi nga magkakaproblema tayo dyan sa 0, 0. Kasi alam natin na either there are infinitely many solutions at x equals 0 or initial point, there would be initial conditions for there would be or no solution at all passing through points of the form x equals 0. All right? Kaya medyo may lull dyan. Tapos dun sa homework, pag ginawa niyo yung homework, ganito yung gagawin nyo. So kailangan nyo mag-trace ng isang solution. So, pwedeng gawin nyo ay, say, ito yung napili mong point kung saan ka magkakaroon ng solution. And then, kunin mo lang yung mga points na yan. And so on, tapos i-connect mo lang siya ng ganyan. Right, so, magkakaroon ka na. Ganun. So, that's one of the solutions. So, ito yung parang preview nung gagawin nyo sa homework. Right? So, some curves will look like this, more stiff than others. Right? So, and so on. Pero hindi ko sure kung mag-i-intersect siya dyan. Posible siya mag-intersect kasi there would be infinitely many or there could be infinitely many solutions passing through this point because at that point, x is equal to 0. Kung saan discontinuous si f at saka si partial ni f with respect to y. And remember, the connective there is and. So pag may isa dun sa dalawa, meaning isa kay f o kaya kay partial ni f with respect to y, yung hindi naging continuous at a particular rectangle, ibig sabihin, hindi na unique, o hindi na tayo sure kung meron kang unique solution talaga. Kasi ang usapan dapat parehas sila ay continuous sa isang rectangle that contains your initial point. All right? So, any questions? So, pwede na ba nating iwan yung chapter 1? Okay, so maybe let's have a 2-minute break just to catch some air. Baka too much info na for one sitting. So, sige, reset muna tayo, digest for 2 minutes. Pag-isipan nyo na rin kailan yung gusto nyong deadline ng homework 2. Kaya ba ng Friday o gusto nyo sa Monday na lang? Or gusto nyo mas maaga, pwedeng okay, Monday. Of course, Monday yung sasabihin nyo, no? Kasi siya yung mas mas later. Siya yung later than dun sa dalawang options na binigay ko. Sige, let's do it on Monday, right? Pero again, you can submit as early as you have your solutions, para mas mabilis ko siya nag-gradean, saka para matanggal nyo na siya on your plates. Because I think this would be an easy homework. So okay lang yan, mag-ipon tayo ng points kasi kailangan nating mataas yung points sa homeworks before we go to the exams. Medyo malaki yung percentage ng exams to your final grade. So yeah, let's muster all the points as early as now, all right? So deadline would be on Monday. I'll send an email or an announcement via Canvas later. So para clear sa lahat kung kailan yung deadline. Yes, Gab. What's your question about homework 1 before we start the next set of slides? Yeah, if you want, okay, there you go. May way po ba para ma-check if tama po yung nakuha differential equation for a certain family? Yes. Though, paano siya ma-check kung tama? Kailangan mong isolve yung ODE. Kasi remember, what we did for that particular part of the course ay pabaliktad. So let me just add a page. Ang ginawa natin, meron tayong intended solution. So meron kang family of curves, tawagin nating G, or sorry, G of say, meron kang family G of curves. Nakadepende siya sa parameter, family of curves. So ang hinahanap natin ay ano yung ODE na ang solution ay yung family of curves na given. So it's sort of a reverse process than what we will be doing right now. So para halimbawa may nakuha kang ODE or candidate para dun sa ODE pero hindi ka sure. How can you make sure na tama yung solution mo aside from retracing all your steps from the family towards the ODE? Ang paraan para ma-check siya ay isolve yung ODE. Kailangan mo isolve yung ODE at dapat yung solution na makukuha mo ay equal dun sa family of curves na given. So you solve the ODE. Pero at this point, we cannot do that yet kasi hindi natin na-discuss kung paano mag-solve ng mga ODEs. Once we learn these things, then you can now check what you did in homework number 1. Kasi I think the easiest way to check it is to indeed solve the given ODE. Or pwede ba natin siyang gawin using direction fields? It depends kung yung makukuha mong ODE ay first order at kaya mo siyang isulat explicitly, then you can draw the isoclines or you can draw the direction fields. Tapos dapat yung yung integral curves na makukuha mo mula dun sa direction field should be the elements of your family of curves. So yun lang. Pero analytically, wala pa tayong method or hindi nyo pa kayang gawin ngayon kasi hindi ko pa naituturo kung paano mag-solve ng mga ODEs. Pero ang idea, kung meron kang candidate ODE para dun sa family of curves, isosolve mo yung ODE at kailangan mapakita mo na yung solution ng ODE na yon ay equal dun sa family. Alright? I hope that makes sense. Kaya, kailangan nating simulan paano nga ba mag-solve ng mga ODEs. Alright? Yeah, it's a nice segue. And what we want to do now is to look at different classes of ODEs at kung paano sinosolve yung bawat isa sa kanila. Right? So I think here I have, or in this chapter, we'll consider ordinary differential equations of order 1. So makikita nyo na, okay, or isipin nyo, okay, order 1 ODE, madali lang dapat yan. Alright? Kasi y prime lamang yung derivative na makikita ko dun sa ODE. So that means dapat madali lang yung pagsosolve. But apparently it's not that too straightforward, especially for complicated first order partial differential equations. Kasi di ba alam lang natin na general form for first order ODEs ay y prime equals f of xy. But the complication for the solution will depend on how the function little f looks like. Or actually, paano nga kung hindi pa siya explicit? Paano natin isolve yung mga first order ODEs kung hindi siya explicit at kung explicit man siya, napaka-komplikado na ng function f. Actually, for the course, we will consider 10 types of functions of order 1. All right? So merong 10 klaseng solutions tayong titingnan. And these solutions will depend on how the ODE looks like. So makikita nyo, hindi pala ganun kadali. Kahit first order ODE pa yan, depende pa dun sa itsura ng ODE yung solution nila. And I guess yung target natin for this week is to tackle the first 3. Pero tingnan natin. I always favor depth of discussion rather than the length. So tingnan natin kung aabot tayo, pero ito yung end goal. So we can do sections 2.1 to 2.3. And we will do the discussions plus the homework so that at the end of the unit, you will be able to identify and apply the appropriate method to solve an ODE of order 1. Right? And crucial yung order 1 kasi minsan may mga equations na kaya nating ibaba to order 1. So if you have an order 2 differential equation, there could be a way of writing it as a first order ODE, tapos babalik tayo dun sa solution ng first order na yon to get the solution to the second order ODE. Kaya medyo crucial itong first chapter. At hindi siya ganun kasimple kasi nga 10 iba't ibang posibleng methods yung kailangan natin gawin depende dun sa form ng ODE na given. But let's start with the easiest one first, and this would be the separable differential equations. And I think you have seen this in Math 36? Math 37, tama ba? O Math 38? Kita nyo na ba yan, mga separable differential equations? Or hindi pa? Or kinalimutan nyo na sila? Okay, nevertheless, kung ayaw niyong umamin na nakalimutan niyo na or you don't want to share it. But I guess you should have seen this in Math 37 at least. Ano? Yeah, separable differential equations, as the name implies, sila lamang yung mga ODEs na kaya nating paghiwalayin yung variable y at saka yung variable x from each other. I mean, we can write them in 2 separate sides of the equation. So essentially, sila yung mga equations of the form equation 1. Siya ay pwede mong isulat, say, in an explicit form. So y prime. Again, sa chapter 2, ang isipin lang natin, first order lahat. So you start y prime equals a function of purely x and a function of purely y. So yung right-hand side ng explicit ODE ay kaya nating i-factor into two functions, right? Where the first factor only has x's in it and the other has y's in it, right? Bakit siya sinabing separable? Kasi nga, una, yung right-hand side, kaya mong i-factor na magkahiwalay yung dalawang variables. And I think the more obvious reason why it's called separable is because lahat ng x's pwede kong ilagay sa kaliwa, tapos lahat ng mga may y's kaya kong isulat sa kanan or vice versa. So if I can write my ODE in the form equation 1, I can simply multiply both sides by dx and divide both sides by h of y to have the following equation. dy over h of y equals equals f of x dx. Right? And now the two variables are separated from each other, meaning all the y's are on the left, all those with x's are on the right. Separated na in dalawang variables. Okay? And then once you have separated them, we can simply integrate both sides. Because again, the goal is to find the function y that satisfies the given ODE, right? And meron akong dy. Para mawala yung differential with respect to y, kailangan ko lang mag-differentiate. Mag-integrate. Kasi pag in-integrate ko to, nawawala na yung dy. So dito, puro variable y na lang yung matitira. In the sense na wala na yung differential. Mawawala na yung derivative with respect to y. Ganun din naman sa kanan kasi mawawala naman yung differential with respect to x. So meaning after we carried out the integration, then makukuha na natin yung solution dun sa OD kasi makakuha na tayo ng isang function o isang relation na wala nang involved na differential o derivative. Right? Alternatively, you can say, ito na yung sinasabi ko kanina, pinaghiwalay lang yung variable x saka yung variable y. Okay? Now, let's just try to see why the following are separable equations. First one, dy over dx equals 2xy squared. So bakit siya separable? Separable because I can multiply both sides by dx and divide both sides by y squared to get the following form. I'll get dy over y squared equals 2x dx. Separated na in dalawang variables. Okay? Next one. Y prime equals cosine x times cosine squared to y. Ito, medyo kumukomplikado na siya. Pero in any case, first, I'll write y prime. Sulat ko muna siya as dy over dx. Tapos meron akong cosine squared x times cosine squared 2y. And then I can multiply both sides by dx and divide both sides by cosine squared 2y, and we'll get the following. dy over cosine squared 2y equals cosine squared x dx. The variables are separated, so that means equation number 2 is a separable differential equation. All right? And then the third equation, ganun din. Mag-divide lang ako ng square root of 1 minus x squared from both sides. And then I think I'm done. Separated na yung y at saka yung x. So I hope this rang several bells. Natatandaan na at least kung kailan siya separable at hindi. Tapos alam na rin naman natin yung solution scheme. Pag separable na siya, dadali na tayo ng integration. But that should remind you na kailangan tandaan natin yung methods of integration. So kailangan babalikan natin paano nga ba mag-integrate. Because we might encounter very complicated integrations depending on how the respective functions involved look like. Katulad nito, meron kong arcsine of x. So dapat tandaan natin paano nga ba mag-integrate kapag may kasamang arcsine of x. And unluckily for you guys, meron tayong face-to-face exam. I'm not sure kung papayag kayong magkaroon ng cheat sheet for derivative formulas and integral formulas. So, as early as now, start memorizing them again or start recalling them. All right, at least the basic ones, the basic formulas. Okay. Now, before tayo sumabak sa pagsosolve ng mga ODEs, I think we're gonna solve those ODEs that we have seen earlier, those separable differential equations. Bigay muna tayo ng mga counter examples, mga non-examples. Sino yung mga hindi separable? Halimbawa ito, dy over dx equals y plus cosine x. Again, ang goal natin ay ma-factor ito. Sana ma-factor natin ito. First factor being may x lamang, other factor being may y lamang. Kaya lang naka-plus na siya eh. So kahit anong gawin mong factoring dito, hindi mo mapaghihiwalay yung variable x saka yung variable y. Okay, pwede rin naman ang gawin mong solution attempt ay multiply both sides by dx. Separate mo na to kagad kasi anyway, that's what you will do at the end. So pag ginawa mo yun, dy equals y dx plus cosine x dx. The problem here is here. You still have the variable y intertwined with the variable x. Kasi meron kang y times dx, hindi natin ito mapaghihiwalay in the presence of a plus sign. Okay? So that means this is not separable. So the method that we will discuss in this set of slides will not be applicable to this guy. So you need to look for another method para ma-solve ito. Kasi hindi siya separable, hindi mag-work yung integration of both sides na gagawin natin for the previous examples. Okay? Another one, this one, y prime equals tangent of x plus 2y. X and y are joined together with a plus sign, and they are inside the tangent function. So malamang hindi natin to mapaghihiwalay. Well, you can attempt to use the addition formula for tangent. So saan nga ba equal ang tangent alpha plus tangent beta? So, but if you do that, if you expand it using that addition formula for the tangent, you will see meron pa ring factors na magkasama si x at saka si y. All right? So this is a non-separable differential equation. Okay? Then last example, this guy. Bakit siya hindi separable? Because, pag in-expand ko to, meron akong x dy, kaya lang dito ay meron akong negative negative y dx. So magsasama palagi si x at si y. There's no way I can isolate the variable x from the variable y. Okay? So I hope clear kung bakit hindi siya separable or bakit hindi sila separable. There's a chance or there's a big chance that in the exam you will not be told what method to use. All right? Pero siguro, ito lagi yung ginagawa ko eh. Titingnan ko muna kung yung OD ay separable or hindi. Because I think the easiest solution is via separation of variables. Kung siya ay separable, then good. Pwede ko silang i-separate tapos mag-integrate lang ako both sides. So yun yung aking unang ina-attempt. Then if that doesn't work, then I'll look for other techniques. But my first priority is try to see if it's separable because that's the easiest solution, at least for from me. All right. So yun yung pwede nyo gawin. So let's see some examples on how to solve separable equations, but I already alluded to how this is done. So let's look at particular examples. So marami pa sinabi yung slides, pero let's start with this example. dy over dx equals 2xy squared, provided that y is not equal to 0. Ano ito isa-solve? Well, separable ba yan? Actually, isang tingin pa lang dapat automatic na separable na yan kasi naka-explicit form siya. Yung right-hand side, 2xy squared, kaya nating i-factor na yung first factor puro x's. In this case, that first factor is going to be 2x. The other factor na puro y lang yung kasama will be y squared. So this is indeed separable. Actually, after you do the separation of variables, so you can write solution here. Okay. Medyo palaking ko lang ng konti. All right. So mag-start ka sa dy over dx equals 2xy squared. And then we multiply both sides by dx and divide both sides by y squared. So we'll have dy over y squared equals 2x dx. Right? And then you can write 1 over y squared as y to the negative 2 in preparation for the integration. Kasi mas madaling mag-integrate kapag naka-power form yung mga expressions. And then, again, we have mentioned that the key here to eliminate the differentials would be to integrate. After all, integration is the inverse process of differentiation, right? So, integrate ko lang yan. Okay? Now let's integrate y to the negative 2. That's going to be what? That's going to be y to the negative 1 over negative 1. Nag-add lang ako ng 1 sa taas sa siya yung denominator. Plus an arbitrary constant. Let me call it C1. And then I'll integrate the right-hand side as well. Integral and 2x squared. Integral and 2x. 2x squared all over 2. So that's going to be x squared plus another arbitrary constant. Let's call it C2. Right? So don't forget the arbitrary constants because they represent the parameters in the solution. Kaya nagkakaroon ka ng infinitely many solutions kasi nga merong parameters na involved. Merong mga arbitrary constants na involved. Right? Now, but the thing here, even though I have two arbitrary constants, I have here, say, just any constant C1. I just have another constant C1, C2 here. Pwede ko silang pagsamahin sa isa na lamang. So I can write this negative 1 over y equals x squared plus a constant c. Pinag-isa ko na lamang yung constants ng C1 and C2 because C can be seen as C2 minus C1. But since C2 and C1 are both arbitrary, then their difference, C2 minus C1, is also arbitrary. So I can simply replace it by another name. I'll just call that arbitrary constant C. Kaya nga after, ito na yung gagawin ko later, after differentiating, after integrating, pwedeng dun na lang ako sa isang side maglagay ng arbitrary constant C. And that arbitrary constant C will represent the arbitrary constant from both sides of the equation after the integration. Okay? And then this could qualify as your solution. So pwedeng yan na yung ilagay nyo na final answer kasi okay na yan kasi wala nang derivative na involved. So we could have stopped here, pero if you want to get a better representation for the solution, you can write it as what? Na naka-explicit in terms of y. So you can multiply both sides by y and divide both sides by x squared plus c, and then flip the equation. We'll get y equals what? Negative 1 over x squared plus c. And this would be our general solution. All right. And that's the general theme on how to solve separable differential equations. All right. Everything's good? So kita nyo na kailangan mag-review ng integrals at derivative. All right. Sana hindi ma-deadbat si tablet ko. All right. Okay, let's try another one. Let's have xy dx minus x plus 2 dy equals 0. So this is a little different because this is not in explicit form. So paano natin itatry kung siya is separable? So let's do the brute force thing. Let's try to separate the x's from the y's by using simple algebraic manipulation of the given equation. So if I'll write a solution for this, start solution, tapos ang gagawin ko, copying ko si problem, xy dx minus quantity x plus 2 times dy equals 0. Again, I am hoping that it is separable. So gagawin ko, sige, try natin. Paghiwalayin nga natin yung mga y at saka yung mga x. So I'll do transposition first. I'll have xy dx equals x plus 2 dy. Right? Nag-add lang ako ng x plus 2 dy to both sides. And then, i-divide ko lang ng, i-divide ako ng y mula dito kasi ayokong may y na kasama kay x. Tapos ito, oops, may x plus 2 pero ang kasama niya ay y. So I'll divide both sides by y and x plus 2 as well, right? Para ma-separate na yung mga variables. So if I'll implement that, we'll have what? We'll have x over x plus 2 dx equals y, equals dy over y. Okay? Good so far? Separation of variables. Tapos ngayon, mag-i-integrate na ako. So this will be, madali yung right-hand side. Simulan ko na yung right-hand side and I'll flip the equation. Integral ng dy over y. Remember, that's going to be ln ng absolute value ng y. So that's fine. Medyo mahirap yung sa kanan kasi integral siya ng x over x plus 2 dx. paano nag-i-integrate ng rational functions of this form? Well, I guess we need not be fancy about it. I can just let u to be equal to x plus 2. That means du will be replaced by dx, and x will be replaced by u minus 2. So you can box the substitution statement that you used para lang alam ko na ito yung substitution na ginamit nyo. Alright. And then let's implement that substitution. So I'll have what? Integral of u minus 2 all over u du. I can further rewrite it as 1 minus 2 over u times du. Tapos, mag-i-integrate na ako. Madali na itong integrate kasi ano na lang siya, difference ng dalawang functions. So its integral would be u minus 2 ln of absolute value of u plus the arbitrary constant c. And then we'll revert to x. So gawin ko na lang siyang ln ng absolute value ng y equals, si u ay equals to x plus 2. So I'll have x plus 2 minus 2 ln ng absolute value ng x plus 2 plus the arbitrary constant c. You could stop here because wala na mga variables involved. Pero kung gusto nating simplified yung final answer, we can write it this way. Paano natin siya gagawin? Let's try. So I can have ln ng absolute value ng y. Pwede ko itong isulat na x plus 2 minus ln ng quantity x plus 2 squared, right? Because loss of exponents tells us pwede na yung pumunta dun sa taas, umakyat ng ln. Tapos nagkakaroon ka ng absolute value ng x plus 2 squared. Kaparehas na lang yon ng ln ng x plus 2 squared. Kasi positive lang naman palagi yung x plus 2 squared. So I can drop the absolute value bars. And then I'll have a plus c over here. Then, copy ko lang to. Papunta sa next slide. Copy. Tapos, para si y ay ma-isolate, pwede kong erase both sides kay e, right? So I can use e as the exponent, as the base for both sides of the equation. I'll have this. Tapos, isi-simplify ko na lang ito. E to the ln of absolute value of y, that's going to be the absolute value of y equals, ano mangyari dito? I'll have e to the, well, e to the x minus ln. Pwede ko siyang paghiwa-hiwalayan. E to the x times e to the negative ln of x plus 2 squared. So I'm using the addition property now of exponents. So this will be e to the c. All right, everything's good so far? Tama ba? Tapos ito ay magiging absolute value ng y equals e to the x. Tapos ito, yung negative sign sa harap na multiplier na negative 1, pwede ko siyang iakyat. So mapupunta na lang siya dito. Okay. So that means the second factor here can be written as, can be written as x plus 2 to the negative 2. Kasi nga makakancel lang si e at saka si ln. Right. Tapos si e to the c, nawala pala yung plus 2, no? Kasi meron pa palang plus 2 rito. Isinama ko na siya dun sa arbitrary constant plus c kasi pag meron akong arbitrary constant, dinagdagan ko siya ng isang fixed constant, right? This guy will still be an arbitrary constant. So this c plus 2 is an arbitrary constant. E raised to an arbitrary constant is another arbitrary constant. Actually, not another arbitrary constant, but a positive arbitrary constant. So I can multiply this by k and take note that k is any constant that is greater than 0. All right? And then, tingnan natin kung magkakaproblema tayo doon. This is absolute value of y. Pero, yeah, can we write it in a better way? Yeah, I think we're good. We can just write it as absolute value of y equals e to the x over x plus 2 quantity squared times k. Yeah, and then y can be negative kasi naka-absolute value naman siya. All right? And yeah, you can leave your answers like this. So that means the explicit solution, y is either equal to k times e to the x over x plus 2 quantity squared, or it is equal to negative e to the x times k all over x plus 2 quantity squared. Oh, that tells me, pwede pala na isulat ko na lang to as y equals e to the x over x plus 2 quantity squared times, say, capital L, where L is any constant. Kasi nga kung kukunin ko yung negative value ni y, kasi naka-absolute value naman siya eh, pwedeng equal siya dun sa negative yung k na multiplier. So you can, so the final answer, the simplest form of the answer is this guy. Ang solution niya ay e to the x over x plus 2 quantities squared times an arbitrary real number. Okay? Kasi nga, if you remember yung definition ng absolute value, explain ko lang mabilis kung bakit ganun yung nangyari. Maybe here. Remember, ang ibig sabihin nito is either y is equal to e to the x over x plus 2 quantity squared times k, or y equals the negative of e to the x over x plus 2 quantity. Right? Yan yung dalawang possibilities for the solution kasi naka-absolute value yung y. Pero pag itong negative sign dito, isinama ko dun sa k, right? Naging arbitrary constant na lang din siya. So ibig sabihin, the arbitrary constant can be positive. Makukuha natin yung positive root. The arbitrary constant could be negative, pero makukuha ko naman yung negative root, right? So that means I can join these two cases together into one. That means y equals e to the x over x plus 2 squared times an arbitrary real number L. Hindi ko na kailangang i-restrict si K to be positive. Kasi pwede pala siyang maging negative provided yung negative root yung hinahanap natin. Okay? So probably we can stop here. And then on Thursday, we'll solve the rest of the examples. Remember, this is the third separable differential equation na nakita natin dun sa examples. And I think we can take a look at, may isa pa pala. Ito pala yung third. Second pa lang pala yun. And let's see, what else? Oh, and then exercises na ulit. Okay? Any questions? So nagsisimula na tayo ng fourth question. How do we represent the solution? And so far, as long as we have a separable differential equation, we have an answer to our problem earlier, or to that fourth bullet. Alam na natin kung paano mag-solve ng solutions kapag separable yung differential equation. All right? But again, it requires a knowledge of basic integration and differentiation formulas. So before we meet on Thursday, I hope you review your derivative sheets and your integral sheets para we can have a meaningful discussion about separable differential equations. Because spoiler alert, yung susunod na method, which would be the method for solving ODEs involving homogeneous functions, ay separation of variables pa rin yung solution. Kaya hindi masasayang yung pag-review nyo ng derivative at saka integral formulas. Gagamitin natin yan ng paulit-ulit. Okay? So that's all from me today. So any questions, guys? Any comments? Masyado ba akong mabagal magturo? Parang hindi ko na naman matatapos yung coverage na supposedly meron tayo ngayon. Pero that's fine with me. Kung masyado akong mabagal, just let me know. I can pick up the pace. Pero yan. All right? So if there are no concerns, thank you for joining me today. Enjoy the rest of your day. And let's see each other again on Friday. All right? Thank you, guys. Bye-bye.
Thank you, sir.